Perfect squares. When determining perfect squares, we know that the perfect square and square roots are related to each other. So we know that the number 25 is a perfect square, and it's formed by multiplying two factors of 5 together. So we know that 5 times 5, or 5 squared, equals 25. So when we're looking at perfect squares, 5 and 5 are prime numbers, and they are the only solution to 25. If we had a larger number like 1764 here, or in B, 1296, with a calculator, these are easy. The square root of 1764, if you put that in your calculator, you get the answer, which is 42. And the square root of 1296 in your calculator, easy enough, punch it in, comes up with 36. But what if you're asked to find the answer, but as a product of its prime factors? So you're asked to find the answer, 42 for 1764, as a product of its prime factors. How are you going to do this? Well, the first thing you're going to do is you're going to start a little tree. This is method number 1, by using the tree method. So I'm going to first, because I know it ends in 4, I can actually divide by 2. That gives me 882. And I'm going to keep breaking this down by 2 until I can't anymore. So 2 times 441 is 882. Oh, it looks like 441, it's not ending in 2 or 4 or 8, so I'm not going to be able to divide by 2. I'm going to try 3. That's the next prime number, and it does work. It's 147. And then again by 3, and I get 49. And we know 49 is a perfect square for 7 times 7. Now, what I'm going to do is I'm going to group the factors in pairs. Let's spell pairs so you can actually read it. In pairs. So, as I group the numbers, I have a 2, I have a 3, and I have a 7. And then I'm going to take the other ones, a 2, a 3, and a 7. I'm just separating them out because I have 2 of each, so I'm just going to separate them out. And the reason I'm doing that is because if I separate them out this way and multiply them together, I find that 3 times 7 is 42, or is 21 times 2 is 42, or 6 times 7 is 42. Well, that's what we found out through our calculator. These are the factors, 42 times 42. This is a way of grouping the factors into pairs of prime numbers. Let's try 1269. So I'm going to start again with dividing by 2 first. Gives me 648. And then by 2 again, gives me 324. I'm going to divide that again by 2. Gives me 162. And divide that again by 2. Gives me 81. 81 is not divisible by 2, so I'm going to try 3. And that gives me 27. And I can do 3 again. Gives me 9. And 9 breaks down into 2 3s. So if I look at this, I want to break this up into groups again. Where's my groups of factors? I'm going to group my factors. So I have 1, 2, 3, and 4. So there's 3 and 4. And I have 1, 2, 3, and 4. So I'm just going to group them this way. So I will have my 2 times 2, so that's 2 squared. And I have 3 times 3, or 3 squared. So that's my first grouping. So now let's look at my second grouping. It's 2 times 2 times 3 times 3, or 2 squared times 3 squared for my second grouping. And of course, those each equal 4 times 9 is 36. 4 times 9 is 36, which we found through the calculator are the perfect square for 1269. Now for your own practice, I'd like you to look at 3300 and 2646. What I'd like you to do is pause the video, try those two using the trees, as in the two examples above, and then restart the video to find the answers. Welcome back. You should have gotten, as the prime factors, 2 squared times 3 times 5 squared times 11 for 3300. And for 2646, you should have gotten 2 times 3 cubed times 7 squared. Now there's a difference with these two in the fact that I won't be able to group them the way that the above examples were, but it was a good practice for using the tree to decipher what the prime factorization of each of the numbers is.